scared about the fitness coach stuff because they're like any good fitness teacher. Like this one teacher I have said, I mean, she has apparently an accent, but like apparently she's actually.
All right, welcome everybody. We have a bit of a quorum here, so we'll get started. Those who are late can watch the replay. MK, who y'all met on Friday, did reach out to me. Just to remind you, he's sincere about this. Find him on LinkedIn, MK Palmore. He truly is an advocate for people starting their career in cybersecurity. So do friend him. I mentioned this to some of y'all. He was actually featured in Business Insider on Monday, which is pretty good article. It's behind a paywall. I'll probably share it in lab, but kind of interesting. So reach out to MK. As for me, I will talk to y'all about how we're going to sort of facilitate that, because you can like randomly make friends with people on LinkedIn, but I want, people who are actually interested in keeping in touch with me once we complete our journey here. I want to make sure we do stay connected. On that note, Jess, we do have a visitor from Google today. Jess, would you like to just introduce yourself, say hi to the class?
Hey everyone, I'm Jess Hill. I'm at Google. I work in our New York office. I've been at the company for about 11 years, and I lead the Google in Residence program that Dan is helping us with that has Googlers come in and teach across all different HBCUs and HSIs. So thank you for having me.
So office hours after class today, the normal 3 to 5. We're going to step out for a quick meeting with Dr. Roy, but anybody who wants to use 454, I'll have the room open, and we'll be there from about 3:30, 4 o'clock onwards. So, all right, on to today's agenda. This is probably by far my favorite chapter for a lot of different reasons. I think it hits on a lot of my core competencies, really. And it takes us a little bit out of the coding space, which I truly enjoy, but it really allows us to like connect some dots, like the real world to the coding world. So if you hadn't had a chance to look at chapter 10 yet, it's titled Inheritance. So we're talking about subclasses for those who know a little bit about that. But we're also really talking about diagramming and unit testing. We won't get to unit testing today. We'll get to that on Friday, but we should get through most of the diagramming today. So, why diagramming? Imagine we lived in a Star Wars world and we had to build a TIE fighter. I'm sure if we were smart enough engineers, we could just sit down and start welding and putting pieces together, and we can come out with that. But we might make some mistakes, right? This looks to be pretty sophisticated. And we really need to think about our software in the same way. The software we're building, I don't know, it's not like, I guess if you're going to write a paper, you should do an outline. But this is a little bit more detailed than just doing an outline. We have to think about a lot of different factors, right? So generally a blueprint, at the end of the day, it's all about money. It's cheaper. It's cheaper if we think about things up front. I think it's on this slide. Shout out to my father. I think I mentioned this to some of y'all. My father was a contractor. And so growing up, he built about 5 houses when I was in my teen years. And I helped him do that, worked my way through high school and college as a mason's assistant. And my dad used to always say, measure twice and cut once. So I don't know if that resonates with anybody. Once you cut that piece of wood, that's it, right? If you make a mistake, it's gone. So this is what blueprints allow us to do. Taking it up a level, kind of from that physical world. When I think about being a software engineer, and who are my software engineers here? So again, we all wear different hats, but the software engineers, yeah, you're doing the coding, but you're also doing a lot of the planning. You're figuring out how are we going to build that ship, right? And you're going to coordinate all those other developers to make sure you're all building the right pieces at the right time. They allow us to communicate, right? And hopefully you've learned from this class. I do respect people learn in different ways. Some of y'all take away from my lectures when I speak. Some of y'all don't. But you have Zybooks. Maybe you learn better with Zybooks. Maybe you don't. Maybe you learn better with the assignments, right? So we always look for different ways to get our point across. a lot of what we're doing is very complex. You know, obviously to date, we're doing a lot of Mickey Mouse scripts, right? Reverse a string, find the third digit, stuff like that. But as you probably come to appreciate with classes, the last module, right? Now we're starting to build real world constructs. The last point is it allows us to legalize our work. And I'm going to share some stuff that I've been involved with. And we'll talk a little bit about informal diagramming and talk about some formal diagramming. So the first thing I want to talk about is this. So not all of our diagramming is very, you know, follows the same pattern. We just need to get our point across. This is a 3-page pattern. That's it, right? What is this groovy thing trying to tell me? Well, I was building a system, I think it was probably back in 2013. We got the patent in 2018. And when we use a phone, what finger do we use the most?
Thumb.
The thumb, right? So we had this idea, me and my partner who was working on this. Let's navigate our apps just by going like this. And we called it Orbit. And so the idea with this patent was, oh, okay, we had an application, it was sort of modeled after Microsoft, where you had a calendar, you had email, you had a chat system, maybe you had a payment system, something like that. This is, if we had like a gigantic screen, this is what our app would look like. But what we said was like, well, if we're a cell phone, this is all you see. So this is a little button. And sort of in our minds, these screens exist. They really don't, right? We just paint into view. This is kind of like as the screen's going out of focus, this, right? That picture is all it took to get a patent, pretty much. So these can be very, very powerful, right? Now, in some cases, they can be a lot more complex. So this is another patent that I have on how phones communicate with big companies. I don't know if Jess remembers this. I don't want to date Jess in any way, but like there used to be a point in time we all walk around Blackberries, and companies had this bright idea when iPhones came out. They said these Blackberries cost us about $3,000 a month. Dan's walking around with his own phone. Why should I pay for a Blackberry? And so they said, great, we want to put our corporate information on Dan's personal device, but we want to make sure it's secure. We want to make sure, to be blunt, if we axe Dan, we can nuke the data on his device. That was the core problem we were solving. And so we had to get our point across why this was a value proposition, why this is something that didn't exist in the world. And so we have a bunch of pictures. That's it. So here we made the point, well, our system can work on a mobile phone, it can work on a desktop, it can work on a tablet, right? It has some applications. It communicates over the internet to a gateway, some company, and it does two things. We can manage the application, and then we can serve email, let them browse the internet, let them chat, things like that in a secure fashion. Some of the diagrams that are in here, and we're not going to get too far into this in this class, but they start to get very formalized in a language called UML, Unified Modeling Language. And that's what chapter 10 is about. This picture here specifically, from what we know already, each one of these boxes, you know what they represent? A class. These are classes in our system. So we created a class called the device. We created a class called the gateway. We created a class called the authorization service. These lines, any guess what those lines represent? If these are classes? Methods, close. They're methods. So my device had a method called getDeviceID. much like we had a thing called product that had get name, right? So what we're learning in chapter 10 has real world ramifications here. This isn't just theory. This stuff is very useful to get you through the next couple classes, but this is the stuff, the skills that you're going to need when you go out into that real world. If you want to go from being like, I'm just a good coder, I'm just a good computer scientist, to like, I'm the top of my field, right? You have these skills, you have the ability to communicate in a way that is not just industry standard, right? But like accepted across the world. So, all that being said, I do have some funny anecdotes that happened. This was a very strange period of my life. I hope we get to talk about time in this class. We had to deal with a lot of time shifts. What happens if somebody tried to jack their phone, right? How did we say if somebody tried to turn the clock back? You know, you're supposed to reset your password every 90 days. If somebody manipulated your phone, how can we detect it? Stuff like that. It was sort of like crazy mind stuff. So, all right, UML, the topic du jour. We've been talking about this menu metaphor, right? So this shouldn't be a big surprise. You can probably just look at it and identify things that we've seen before. We threw out some of the terms already: attributes, methods, class name. We talked about the menu item as another class, right? Same thing. It had its own set of attributes, its own set of methods. And to kind of build on that, I'm introducing another class here called a restaurant. So imagine a restaurant has multiple menus. Each menu has one or more menu items. Again, just because you saw the metaphor before, hopefully this is apparent. In this top box, you just put the name of your class. In the middle box, you put your attributes. And there's 2-3 special symbols that we have to be familiar with. If the attribute is public, we want people to know about it, we put a plus sign. If it's something that's private, we put a minus sign. So the example here is, if I had chicken from KFC, right, the Colonel's 7 herbs and spices would be the secret sauce. I wouldn't want other people to know about it. Now, I heard people talking about Java. This makes a lot more sense in programming languages like Java, where the concept of private is respected. It basically means other classes can't access that data. Python, no such thing exists. It's a concept. You can see the code all the time. You can see everything that's public. You can see everything that's private, right? So there's just some notational stuff that's in that PIP 8 guideline. If we have a method and we want it to be private, we put an underscore on the method, stuff like that. But really, everything's public. When we write them out in UML, though, we're sort of saying what our intent is. In addition to classes existing on their own, classes have a relationship to each other. So we talk about a has a relationship. A menu has a menu item. It actually has many menu items, but just generically we say has a. Not thinking of this as food, but as a menu item. Can a menu item exist on its own? Does it make sense? No. A menu item, without a menu, it doesn't make any sense. Can anybody think of a similar relationship where like some entity can't exist without some other entity? I like the way you're thinking. That's very interesting. I'm thinking more in terms of like an object. Is there some object that can't exist unless it had all these other things? An element of a list, I guess. I mean, but an element might exist on its own, right? I could have integers and strings, like they can exist, but at a more concept level. A what? A plant, like, so give me an example, like what part of a plant couldn't exist without the plant? Okay, it might need that. I guess I would think it more like a plant, like a root on a plant. A root can't, like, without a plant, the root doesn't make sense. That's kind of a good idea. So when we use this has a relationship, we say composition when kind of these things doesn't make sense for them to exist on their own, right? I would make the argument a class consists of students, right? Does it make sense to have a class without students? I mean, it would just be pointless. I'd be just talking in the wind, right? There's another type of composition, or sorry, has a relationship called aggregation, right? And this would be the relationship between a restaurant and a menu. So we can imagine menus can exist without a restaurant, right? Where else might I use a menu if I'm not in a restaurant?
Fast food.
What's that?
Fast food place.
Sure. Maybe it's a fast food place, not like a sit-down restaurant. Maybe it's a corporate hotel, a corporate, dining hall. Maybe it's a buffet or the conference center, something like that. So we say a restaurant, this menu thing can exist on its own, but I want to recognize that there is a relationship here. Now, I want to point out two things. Whenever we have this has a relationship, you're probably going to have an attribute on this side that has a collection. So you're going to say, here's my menu items, right? Here are my menus. In this case, I chose to do a dictionary. In the previous case, I chose to use a list. No rhyme or reason, just whatever makes sense. I don't know why. Oh, yeah, I know why that's there. So putting it all together, I could say this restaurant has menus. Menus have menu items. Okay. We're going to look at in a second here how to draw these diagrams. Why? Because you're going to be drawing these diagrams. When we do assignment 10, you're going to be drawing. I'm going to give you some classes, and you're going to draw the diagrams. And then I'm going to ask you to draw a diagram and produce the class. Right? So inside the Blackboard, up inside course content, you'll see UML diagramming tool. Easy to remember. It's just draw.io. So if I go to draw.io, it's going to take you out here. I have a couple of diagrams already created, and I'll show you how to create them yourself. Basically, you'll be given this panel. At the bottom, you have a bunch of tabs. So if you want to create a new page, whatever, here's a blank canvas. You'll notice on the left, UML. Now, if you want to, you can use different tools. I personally think this is a really good tool. It does a really good job of giving me all the classes, all the lines, all the stuff I need. So when I want to create a class, I just click that. There's my class. I can change the name. That's my menu. And here, what are the attributes? So we said our menu had a name. Instead of the word type, I actually want to say what the type of that data is. So what type is name? Yeah, strings, perfect. All right. If I want to add another one, I can just make that a little bit bigger. And I could say, maybe I want to make this private, right? I could say these are my menu items. And that could be a list or a dictionary or whatever. When I have my methods, I do the same thing. Maybe I have something called getName. Does it take any parameters? Let's say no. And what's getName going to return? A string. And then if I want to create another method, just extend that. Maybe I have a method called, I don't know, get the chef that came up with that. And that returns a string. Now, notice I'm not putting self in there. Really, self is a Python construct. It's not a general concept. This self concept doesn't exist in other languages. So I encourage you not to like pollute this with that extra information. Everybody's going to know you have to pass self into your methods inside Python. So if I have other classes, like my menu item, when I want to associate them, I just look for the association that I want to use here. So I have my aggregation, ooh, implementation, no. What did we say this was? This was composition. Just draw my line. So 2 words of warning here. Number 1, I'm guilty of this. In fact, I probably did it far too long for this lecture. You're going to have a tendency to want to make this darn thing perfect. You're going to want to like have everything lined up, and you're going to move this over here. You're going to take this line. You'll be like, oh my gosh, it doesn't line up. You're going to drive yourself nuts if you try to make this perfect. So my advice to you is just kind of get your point across, right? So this was something I worked on for a while, but get your arrows generally just so you get your point across. That's what we're trying to do. Just get your point across. It doesn't need to be perfect. I will not be grading you on how perfect this looks. I will be grading you on like, well, did you realize there was an association? Did you have an attribute that was intended to be private? Did you put the minus sign? Things like that. Okay. So again, if you get lost, you can't remember draw.io, inside Blackboard course content, UML diagramming tool. Okay. Again, I just had too much fun with this. My personal life, I told you, I love unit testing. I think it's one of the things why I like teaching so much here. Some of my other GIR peers, they like manually grade your assignments. I don't manually grade your assignments. That's why you get like 70% from unit tests. I write those unit tests. I enjoy this so much. Y'all know I like to travel a lot. I used to travel like extensively. I used to just unit test. I used to just get on a plane, have a list of unit tests, and just go to town for hours. Loved it. All right. So how do I take this and turn it into code? It's pretty easy. And we've actually already done that. We kind of did it backwards. In fact, I kind of wish I taught you the diagramming before I taught you classes, but such is life. So now I have this concept of what I want my system to do. How do I implement it? Well, this is where stubbing is going to be your friend. So I want to create a couple classes here. This is how I would start. Class, restaurant. Serves food. Every class needs a constructor. Def init self. What are my attributes? Name and menus. Name, menu. Put a doc string here. Store name and menu. And please, folks, this is all I really expect for your doc strings. I do appreciate the long, big-winded ones, but not for this. Yes, sir? I do. Good eye. Thank you for that. And that is, see, that's exactly the stuff. Remember what I said for assignment 9? Me and the TAs are going to be watching how many times you do stuff. Like, trust me, it's obvious when people are using AI because it's perfect. It's mistakes like that right there. Thank you for pointing that out. That I probably would have run that up and it wouldn't have worked. So. Not like that, but other languages have their own idiosyncrasies. So other languages might say, you know, instead of a colon here, you have to have a curly brace. In other ones, thank God Python and COBOL are pretty much the only ones that care about indentation. Other ones don't care about indentation, but Python does. Okay, so when I have a diagram like that, this is all I'm doing. That, period, stubbing it, pass. Okay, let's run it up. Cool, nothing broke. All right, like I mentioned, let's do the attributes while we're here. Self.name equals the name, and self.menus equals the menus. And I guess then I can get rid of the past. Run it again. Okay, nothing broke. And I have one method, def get menu, and it takes a menu name and it returns a menu. Interesting. Okay. Given a name, return a menu. So that could give me a hint here. If I'm taking in something called menus here, and I'm going to have a method called get menus and it takes a name, likely what data type is menus?
Like tuple, dictionary.
Dictionary. Yeah, key value pairs. So I'm going to stub it, pass. All right. What do I always say? We're lazy. I'm going to take that class, paste it. What's my next one? Menu. Lists. What does this take? This takes name, menu items. I have to use a little judgment here with tax rate. If you remember in our problem, we decided that was better served as a class level variable. So maybe I'm going to just put that there. So our tax rate is 8%, something like that. And this has a method called print menu. Prints the menu. And maybe here, I just want to do something like this, since it's a void method, just do fix me. Okay, everything works. I'm going to suggest the following. Sort of my own fault, I guess, because I do so many darn unit tests on your assignment. A lot of people are becoming like uber dependent on those. That's cool. That's going to work for now. When you start writing your own classes, I'm not going to be writing unit tests for them, right? So how are you going to test your code? Well, you're going to test your code in the main. So you can be doing that today, right? So as you're developing these assignments, rather than just hitting mark all the time, you can hit run as well. So here, maybe I want to create my menu, right? M equals menu. And what did that take? That took a name. We'll call it breakfast. And for now, let's just stub that out. Did anything break? Yep, something broke here. Menus is not defined. So what did I screw up here? Oh, this is menu items, right? Again, what I'm demonstrating here, this is that iterative development. Ooh, I made a little mistake. I fixed it. I didn't go on and write 700 lines of code. And then I'm going to say m.print menu. The function. Oh, didn't work. Menu, print menu didn't work. Take 0 positional arguments. What did I do wrong with this? What's wrong with that method keyword there? What has to be in my parameter list on every method? So self, yeah. So I didn't put self in there. Let's put that in. All right, cool. And then you can imagine I would do the same thing for menu items. As always, if you're not coding along, the solution's here. You can see what the fully built out list of this is. I did some groovy stuff with the string we learned last time. Some of the equals method, right? So this is in the last 9 assignment, right? All right. So the ideal solution here. Let's see. Cool. Welcome to Alice's restaurant. We have 3 menus, breakfast, lunch, and dinner. Which menu would you like? Breakfast. Why is that important? Like, do you remember in the beginning here, I said menus was a dictionary, right? So you can interrogate the code, but you can imagine I'm going to call the method get menu. Cool. There's my breakfast menu. Eggs is $2.50. It has 3 ingredients. Steak is $22.50. It has 1 ingredient. What would you like? Let's say we want eggs. Cool. Order has 1 thing in it. Let's also order some waffles. Cool. I'm done ordering. Order has 2 things on it. Your total for 2 items is $15. Right? So again, I'm leaving this as an exercise for you if you want to implement it yourself or you just want to look at the solution, right? This is what you're going to be asked to do in project 2, by the way. So I sort of announced it without shouting it from the mountaintops, but in lab tomorrow, we will be looking at project 1 and project 2. So project 2 is going to have you looking at a whole bunch of code, figuring out what it does, right? And then implementing a bunch of functions. You're not going to be doing it from pictures just yet, but we're going to get in the practice of looking at code, figuring out what's going on. So this is a good place to do that. Okay. All right. The next topic inside chapter 10, and really, I don't know why they named the chapter inheritance. Like everything I just talked about kind of has nothing to do with inheritance. This is inheritance. Derived classes or subclasses. I thought this was really timely. So a very good friend of mine, and if you want to follow someone on LinkedIn as well, his name is Andrew Stellman. Back in the early 2000s, did we talk about agile programming? Anybody ever hear of agile programming? So back in the day, the way you used to implement stuff was called the waterfall method. Anybody hear the waterfall method? So you did, yeah. So the waterfall method was basically this. Somebody would say, oh, I want you to build a system. They would go away for 6 months, 8 months, a year, and come up with a specification. So all the business analysts would say, this is the system we want you to build. Cool. They give it to the software engineers, and the software engineers say, cool, we're going to come up with the design. So they came up with the UML and all the Ruby documentation, right? And then they went to the coders and said, okay, now go ahead and implement it. So it took 6 months for the specification, 6 months to do the design, and then developers took 6 months to do the work. Anyone want to take a guess what happened in 18 months? What they were developing was obsolete at that point. It took so damn long that life cycle, that waterfall, do this and then do this and do this, right? The bigger problem with that is the person, it was like a game of telephone. The person who came up with the specification got one little thing wrong. The software engineers got one little thing in the design wrong, and the coders got one little thing wrong over here. And so going through the system, the thing was nothing like what was asked for. So this concept started to emerge in the 90s-ish called Agile. And it was sort of like rapid development, rapid prototyping. It was like, okay, what do you want me to build? Build a menu system. Cool. Software engineers, build a menu system. All right, do you want menu and menu items? Does that sound good? Yes. All right, cool. Coders, start coding it. That's it. And then they started to work on it. And you went back to the person who gave the specifications and said, is this what you wanted? And they said, oh, yeah, it's a menuing system, but it's not for food. It's a menu system for Amazon, for products. Oh, cool. Well, guess what? You spent a hot minute doing this. You still built a menu item, but you didn't spend all this time working on ingredients. Does food have allergies and all that stuff, right? Long story short, Andrew is an agile coach, and he started modeling one of the teams I did when I was at a bank. He modeled our team to teach agile. Anyways, last week, guess what he posted? An awesome article on UML talking about derived classes And I thought it was just serendipitous that he was talking about that same metaphor we used, which was an RPG, right? And so what Andrew was talking about was, imagine you're building an RPG, right? And you have two different weapons in your game. You have swords and you have arrows, right? Sure, they have sort of different behaviors, but really in a video game, they're the same thing. They cause damage. So you have a character and you have a health score. Your health score goes down based on your strength and your defense, right? So why do we have subclasses? Why do we do this? The first comment is we want to be careful subclassing. You don't want to do it all the time. If you have one thing in your system that you're building, you have one menu, just build one menu class. And remember, we had this metaphor where we were talking about breakfast menus, lunch menus, dinner menus. If there really is no difference between those, then don't go creating derived classes. I'm going to show you why we might want to do that using that metaphor. But if you're going to write something twice, if you're ever going to write a class and another class, and you're going to put the same exact code in there, the first thing you should say is, wait a minute, let me create a base class and move that logic in there. All right. Before we talk about the syntax, let's talk about the diagramming. So we just learned the UML for a class. Class name, my attributes, my methods. In this case, I'm going to claim a lunch menu is different than a breakfast menu and a dinner menu in that it offers express options. So you can come into my restaurant and I'll have salads and sandwiches ready to go. You can just grab them and go. But you can't come in at dinner time and do that. At dinner time, you got to sit down. So I'm going to claim I need a subclass called lunch menu. But in every other respect, it operates just like a dinner menu and a breakfast menu. I can print it out. It has a list of items. It has a tax rate. It has a name. The notation for this is basically just an arrow. So I have a lunch menu with an arrow, and it's a class. So my class here has a name and an attribute, but no additional methods. So I don't need to pollute it with anything else. To sort of contrive this example, I said, okay, I'm going to claim that we do need a distinct breakfast menu because maybe this was better to say we have syrup options. It doesn't make sense to have syrup options at dinner time. At dinner time, we might have a dessert option and we might have a wine pairing. It doesn't make sense to have those at breakfast, normal. So if I want to articulate this information, that's how I would do it, right? All right, first stop on this crazy train, go over to draw.io. Let's bring this back up. So again, I don't think I want to spend time doing this, but you know, if I had another menu here, let's say I wanted to create a brunch menu. And actually, this is a great metaphor later on. We're going to talk about something called mix-ins. Maybe a brunch menu has pancake options and it has a wine pairing option. So if I so choose, I can create that. And let me just find the nice arrow for that. If I can't find it, I'm lazy. What am I going to do? Copy. There's my brunch menu. It's subclasses menu. I'm going to hint at something that we'll talk about Friday. Multiple inheritance. One can make the claim that brunch is both breakfast and lunch. Multiple inheritance is almost a verboten concept in most languages. You really don't do it. In Java and JavaScript, there's one parent, one child. That's it. They use this concept called interfaces, which we're not going to go deep into. But in Python, they allow you to have multiple base classes, and it leads to all sorts of problems, like you can imagine. How do I know if there's a method here and a method here? Which one can I call? If there's two attributes, how do I know which one I use? There's all sorts of problems. So I'm not going to test you much on that, but this is one of those, just acknowledge that it exists, and I'll show you how it works. But okay, so the derived class, yet another metaphor. If I have a person, we can make the claim that a person has a favorite dish and an age. We can make the claim that a gamer is a person, right? Somebody plays video games like Sage or TA is a person, but he has a list of games. And notice here it's minus games. What does the minus mean?
Hidden.
It's what?
Hidden.
Hidden, yeah, it's private, right? Maybe Sage doesn't want to know, but he plays Dress Up Barbie or something, I don't know. But gamer has a method called play. So a regular person doesn't need a method called play. A regular person doesn't need an attribute called games. So a gamer is a person. How do I implement that? Well, this is the syntax. First thing, we know how to define a class. When we want to define a subclass, it's open parentheses and the name of that subclass. All right? That's not a function. Kind of looks like a function, but it's not a function. The second thing that's unique here, def underscore init underscore underscore is the what? What is that method called? Constructor, right? It's got a very special meaning. I have to explicitly call the constructor on my base class. I have to explicitly say person dot underscore underscore init underscore underscore. Again, people who made Python, sometimes I think they were crazy. Why isn't it just person open paren, right? Pass in self or something. I don't know. But this is what they chose. Notice I created a gamer person. I make no changes to person class, right? Maybe I wanted to create another person called skydiver, right? Not every person's a skydiver, but hopefully every skydiver is a person, right? I wouldn't have to change person at all. Okay, so let's look at what's happening under the covers. This is the same code we just saw here. So I have a class person, I have a class gamer. The interpreter is going to say, ooh, okay, human, I'll acknowledge we have something called person. I'll just record in memory, here's the constructor, and here's my class variable, or sorry, my method. Acknowledges there's the concept of a gamer, and here's its constructor, and it has a method called play. All right, now I fall into my main block. I'm going to create the person Darwin. Darwin, favorite food is sushi, and Darwin plays tag and dodgeball. I guess I was thinking he's not a video gamer. So where does the flow of control go? The constructor of my gamer. Okay? All right. First thing it does, it's going to go to the constructor of my parent class. At that point in time, my first variable comes into existence. My second variable comes into existence. And now games comes into existence. And Darwin exists. So there's Darwin, points at this instance. This instance has 3 attributes. One of them points at a list. That's it. Okay. This, again, I really wish I was teaching this course in Java. I heard the Java thing. Java, you wouldn't have this problem. Java forces you. You have to say super. You have to instantiate your base class. Not in Python. In Python, you can say, I don't want to do that. In which case, your code's not going to work. You're not going to have access to these variables. You're not going to have access to these methods. It sucks, basically. All right. I'm not going to get into this today. We'll do this next time. I'll show you how we implement those derived classes using our menu metaphor. If you want a head start, go ahead and look at it, the solutions there. We'll get into accessing attributes next time. Let's skip this stuff. And what's that leave us with? Leaves us with lab tomorrow. So lab tomorrow, remember, quiz on chapter 9. Classes. It's going to be worth 33 of 100 points. It's going to be the coding section. So we're going to do the coding section, first 30 minutes of lab. Then we're going to work on project 1 and project 2. So this, I hope I have to scrub. It's done. I spent all yesterday working on project 2. I think it's going to be a lot of fun. It's on basically running a search engine. Assignment 9 is due at 11 p.m. So we can work on all of this during the lab period. Friday, we'll take the second part of quiz 9, multiple choice, true and false, open book, all that good stuff. The homework will be due at 11, all right? Monday, code jam, after hours, we'll have the exam prep. I should have that done this weekend. I'll probably let you know if you want to jump into that. And then Wednesday is the exam. Exam on functions, files, and classes. Not this stuff on inheritance. The stuff on inheritance will be our next and last exam before the finals. Any questions? Okay. All right, office hours will be open in 454. I'll be there around 3:30, but if you want to go now, unlock it. Ciao.